Well, hello everyone. If you watched any of my videos, you already know that I'm all about DIY. I really like saving money, doing things my way. I like building things myself, testing different setups, and figuring out what actually works for me in the real world, not just what looks good on a paper. And when it comes to building a high voltage battery system, the mindset has taken me through a few different BMS systems before I finally found one that truly worked for me. And it works at this time. As things change all the time, newer and better things will come out, and we might revisit this topic in a near or a distant future. Right behind me on the bench are the 3 BMSs that I used. So let's go on the bench and take a look at them. Now here we go, start with the Daly BMS. It's a typical red looking Daly BMS with the black and blue negative battery leads. The communication board that is pretty much same for most of the 52 volt systems out there. And Daly BMS also comes with the 2 temperature sensors, which are short leads and are pretty much useless when you need to use them. However, it is my first high voltage BMS. It was capable of 48 cells, about 153 volt system, and it was able to do about 200 amps through itself. I believe that this BMS is originally designed for maybe some kind of a golf cart or maybe some kind of an electric car or whatever they were designing it for. However, we did manage to develop protocol that will talk to Solis inverters. And this was my first try, which I used for a long time. They're a little bit finicky. They will die on you without any reason. And then you will ask yourself why. Typical Daly BMS, but mine's worked. I had about 8 of them. 2 of them did die. However, they did work. The second solution was ENJ Active BMS. I found this BMS on JK BMS website. Okay, I don't know, are they sister companies or one owns another or whatever it is. However, they had this total solution of high voltage BMS. You can see a typical looking blue gray box that components are put into. We will not open up this unit, there's no reason. However, this unit comes with the 4 BMU units which are addressed, okay? And then each BMU units will accept 24 cells to itself. So I had the 4 BMUs for 96 cells, making it the high voltage BMS system. However, I really did not like the design. I think this is more like, well, you know, it's an afterthought. It was made for something, and maybe they couldn't sell it, so they're just selling it off right now as it is. The battery monitor is not the best thing either, okay? So right now, let's pan over it and compare the size of my final solution, or solution that works the best right now, at least for me, is a GCE BMS. It's a high voltage RBMS made by GCE. Here are the specifications of it. It's a 50 amp capable BMS at about 500 volt DC. So that gives you about 25 kilowatt throughput through this BMS. And that's probably why it's so massive and heavy. Now, it also comes with BMUs, okay? And I have 6 BMUs per 1 battery pack, okay? Now, it has a massive cables that already include temperature sensing units. And of course, the positive leads are already for you for the 6mm studs that you might have on top of your cells. It also comes with a professionally made BMU communication cables. I'm really happy with the quality of it. And then of course, because it comes with a terminal connector for the end, probably indicating that these BMU units operate on RS4, some kind of a RS485 protocol. Yeah, they are, because I already have a software developed for it. Okay, this is the front of the unit. Okay, what we have here is two Anderson connectors indicating battery positive, battery negative, and the power positive and power negative. I like that there's a break inside for both sides of the battery. The big on-off switch does include pre-charged circuitry, which we will demonstrate a little bit later. And then of course you have COM units. These are to communicate with your inverters. And this one is a LAN unit. You can hook it up to your home network, or you can monitor it remotely and plus make decisions on it and whatnot. Of course, you can set up protocols and ID tags, and of course the BMU output that goes and talks to these BMU units. Okay, we will go ahead and open up this unit and see what we have inside. Let's see what we have inside. I never actually opened one of these. Here we are. It looks really good made. Everything is nice and tight. Everything has been double checked for connections, screws, everything. They all look nice and tight. I like the way they curved the wires. They didn't just throw them all the way around. Plus, you have this C channel over here for the cables that run through. Wow, I'm actually surprised. It looks decently made. There's a screen right there. I like how all of the cables are inside these C-channel guides and whatnot. Wow, I did not expect this. I like it. What do you guys think? Post a comment down below. Tell me what you think. I really do like the way this is made. Everything has been protected, tightened up. I don't see anything loose on any of these components. Wow. Wow. What is this right here? I do not know what this is. I like it. I think I'm just gonna leave it like this. I'm not gonna cut up this video, this section of the video at all. Just if somebody is able to notice anything. Let me start this part of video, which talks about communication, by saying thank you to John Blance from New Zealand. Without him, I wouldn't be able to talk about any of this. He taught me a lot. So thanks, buddy. Now, when it comes to building a serious high voltage battery system, communication between your battery or battery BMS system to inverter is everything. It's not just about protecting cells anymore. However, when we are talking about such a large amounts of power, you need to be able to say to your inverter, what do you want from it too? So That's where the CAN protocol comes in, and it also works through RS-485 protocol. The CAN connection is how your BMS talks to your inverter. Things like pack voltage, current, state of charge, charge and discharge limits, or charge and discharge amounts of power are all communicated through that communication line. If that data isn't clean or compatible, you'll end up with the charging errors, flickering readings, or a total collapse of the system, okay? Now, here's something that a lot of people don't realize, and that what I didn't realize a year ago is that most often used form of communication is based on Pylontech protocol, either low voltage or high voltage. They set the standards years ago, and even today, most inverter manufacturers, including Solis, use protocol that it's built on top of the Pylontech message structure. So if your BMS can speak Pylontech, chances are it will work with a lot of different inverters, okay? Two protocols, low voltage protocol and high voltage protocol. That is one of the reasons why I decided to go with the GCE RBMS, okay? They already have this standard built in, while DALY and ENJ BMS did not have it. We had to go ahead and develop it. I had to pay extra fees and whatnot. So, what we have here and going forward in this video is based on a Pylontech communication protocol. I just wanted to add that before we move on. Here we are in front of the actual setup. You do see all three BMSs. Okay, so let's get the important stuff out of the way. This is 307 volt nominal system. Please be careful. That's all I gotta say. So, but in a good news, let's talk about it this way. So, BMS, as it is, it's supposed to go in a server rack. That's what it is made for. However, I have adopted it to go on this Husky shelf over here that can carry 10,000 pounds. Okay, now we see all 6 BMUs for this one battery. So we have down there, we have 48 cells, and here we have another 48 cells. Combining it together, we got 96 cells. Okay, so each one of these BMUs handles 16 cells. What's 16 cells? That's your regular old 51.2 volt battery setup. So they are designed, these BMUs are designed to go in one box where 16 cell goes. Now, what has 16 cells? Like million different companies make a server rack setups with 16 cells. That's how they stack these batteries up. So 1, 2, 3, 4, 6, 5. That's how I have them set up over here, connected to all 96 cells. And I have used different stuff and different methods of attachment to those cells. It's important to note that each BMU has 8 temperature sensors. Now compare that to 2 temperature sensors over there at the Daly BMS. It's not even comparable. That's a total of 48 temperature sensing sensors across one battery pack. In addition to that, I have 4 amp JK BMS balancers, since these units can only do a little bit of passive balancing. They can do 200 milliamps worth of passive balancing, but these units do 4 amp worth of passive balancing. I would wish that these BMUs are capable of both. Let's say active balancing, 3 to 5 amps, plus passive balancing. So they can get these 6 different modules of 16 cells to balance in between themselves. This BMS is capable of that. It's capable of balancing the cells and then lowering the total voltage of one module. However, that works extremely slowly once you start talking about 280 amp cells. Now that we got that out of the way, and post down in the comments if you have any questions about this setup, we will go and do a quick tour of how this system starts up once you get it going. Now, before we do that, let's talk about communications. It's only one COM cable goes to the BMS itself, and then it goes cascades from one BMU to another, doing what I said RS-485 communication. The last, number 6, does have terminating resistor. Okay, it's important to install it, otherwise it will not work. And then of course I have a LAN setup over here. This goes directly to my home router, and that's where we see those pretty numbers up in Home Assistant. And then of course COM1 goes straight to inverter, and this carries the CAN communication. Over here we got dry contacts, which I forgot to mention. Okay, so let's go to a different BMS and simulate the startup. Of course, I turned it off. Okay, and this is for inverter 2. Inverter 2 will soon go into yellow once it repeats a communication. There it is. It clicked yellow. It says that it doesn't see battery, it doesn't see communication. Okay, now what we're gonna do is we're gonna turn this on, click, and then it will start up. It's going through a self-test right now. And it goes back into standby mode. Now it will send the CAN communication over here. So any action on these inverters takes about 5-minute timeout. Even though I started the battery, I have to wait for about 5 minutes to reset itself and get the inverter going again. Here we are back at the BMS itself. It's working. It's about 86%. Now the interesting point over here is that shows a state of health 100%. However, that is not true, and it's not working. However, I have found a way to deal with that. Now, we come to that point that everybody sees. This is direct communications from here through a little Python script onto the home server instance that I have installed at the house. It's difficult to talk and record at the same time. But anyways, here it is. So each one of the modules are addressed right here. Module 1, Module 2, 3, 4, 5, and 6. So, and each gives you kind of the most pertinent information. Plus, I made this script. I made the Home Assistant to work where it shows me the highest and the lowest cells per module. Okay, this is very user friendly if you know anything about programming and whatnot. So this was a quick overview of this BMS system over here. Of course, 3 BMSs, as each inverter has to has its own BMS, actually its own battery, and each battery has 6 modules, 96 cells. So that's a total of 18 modules controlling 288 cells across 3 batteries with a total capacity of 255 kilowatt hours. I have not tested that yet. It will take forever to test. But I did discharge it to about 10% one time. And as I said, this is my Home Assistant interface. This is the device that I'm using at the back of my home server PC. plug in there, and then of course it's programmed to collect data from the Solis inverters. Solis inverters are very programmable if you know how to use a couple of lines of codes found in their RS485 interface manual. Here's my Home Assistant configuration YAML. Over here on the left side, and you can see the way I communicate with the RS485 device. And this is the setup to which the Home Assistant is able to talk to the Solis inverters. Okay, over here on the right side is a sample from my Python script that it's installed onto the Raspberry Pi 5 that talks to all three BMSs and then imports data, of course, via MQTT into the Home Assistant. So hopefully this video was not too long. And if there's any more interest, I can show how to go and install all of this. I really can't help you on any kind of other setup that you have, but I can maybe guide you in a correct direction. Okay? All right, I'll talk to you guys soon again. Okay?